tree basics continues. Okay. Now, what were the messages in our DDPs? Okay, Dynamic Trunking Protocol messages. But in spanning tree, okay, all right, we use what are called BPDUs. Okay, in these little bits of information, okay, its job is to find loops in a bridge topology. Okay, now there are ways of blocking or disabling BPDUs or ignoring them. Okay, all right. Now remember what I said before. How you could actually create a loop while spanning tree is enabled by disabling BPDUs on areas that you don't want to. This is a very, very easy thing to do. Okay? Alright, so understanding BPDUs, okay, are very important. Now there's some information in here like the destination address of 018 C200s, okay? Not necessarily something that you need to memorize, all right? But good to know for an exam, all right? However, configuration BPDUs are used for spanning tree to create its topology change notifications, okay? TCNs are sent out when a link is added or a link that goes down to recalculate spanning tree with the BPDUs. Okay? Alright? Now, what is in a BPDU? Well, as you can see on the screen, some information. Okay? Alright? What I like to talk about, alright, is the root bridge ID, the root path costs, okay, the port ID, all right, the hello timers, and the forwarding delay. Okay, so that's not what we're going to talk about at this moment. However, those are the things that we need to focus on. Okay, now, in a BPDU, look at all this information. I mean, all of it. Look at it. Look at it all. Okay, all right, and I highlighted what could be important. Now, I highlighted it. I don't know if I did it or I got the actual picture like this already. Okay. Our root bridge priority. Notice when I actually made that center switch to forward on all its links, I changed the root bridge priority. And I changed it to 0. The lower the priority, okay, all right, meaning that multiple switches in the domain, okay, in the spanning tree domain, are going to compare their priority bridge ID. Whoever has the lowest becomes the root bridge, okay? Now, understand this, okay? 0 is the lowest, and every increment after that is by 4096, meaning that the next priority after 0 is 4096, okay? All right, after that, 8192. Makes sense? Okay? All right? And this is what's in a BPDU message. Now, all jokes aside, okay? All right, hold on, I gotta set my timer because I'm actually cooking something. Come on, stop. Check it in 10 minutes. None of this is going to make sense until we go through all the stuff that spanning tree does. And spanning tree is a large protocol to understand. Okay? And it all starts out with the BID, the bridge ID. Okay? Now, in spanning tree, okay, you got your trees and you got your bridges, right? Okay? All right, you got your root bridge, okay, and you got your priority. Now, your BID or your bridge ID, your bridge identifier, is a combination of the priority value, which I set to 0. Remember that? Okay, and the MAC address, okay, of that switch. Now, if we go back to Packet Tracer, okay, and actually, why even do that? Let's go back to the real switch. Come on. Show in my, I gotta change these settings and make sure they're default here, because I don't like the fact that this keeps changing. Okay, show spanning tree. Now, show spanning tree, and that's the only command, is going to do it for all VLANs. Okay, as you can see, now we're looking at VLAN 20, VLAN 22, okay, VLAN 33. Now, I have to emphasize this. Spanning tree, okay, on a Cisco device is a per VLAN basis, okay, by default. Yes, that means that for VLAN 1, this could be my topology, okay? For VLAN 2, I can have a different type of spanning tree topology, okay? All right? This can be helpful by having some redundancy in your network. Having like half your VLANs running on this topology, half this VLAN running on this topology, so you're using all links. Because you got to understand something here. As these links are being blocked, it's a great topology as far as loop free is concerned, but you are wasting links. They're just sitting there waiting for something to happen. Why not utilize those links by switching, okay, the topology, so the ones that are blocked in one topology, okay, are being utilized in another topology and having other links that are blocked, okay, utilizing your full bandwidth, okay? This takes some skill set. This is something you really got to sit down and think about, okay? All right? But our bridge ID, combination of the priority plus the MAC address, okay? So now, going back to our, notice that, okay, for whatever VLAN that we're on, we have our root ID, which is our priority, plus our MAC address. And it says, literally, this bridge is the root. Okay? And that's it. All right? Okay? That's cool. You'll see more later on as we get deeper inside of it. Okay? So, the root bridge, okay, is the root of the spanning tree topology. Now, what did you consider a root? Think of a tree, because we're talking about a tree, right? Not just the trees dropping on, but the topology itself as a tree. Okay, so now, yeah, now this, the name is actually becoming a little bit less simple or simple-minded, right? All right, it's starting to make some sense. Because now we have a root of our tree. Okay? All right? That root, all right, root bridge, okay, is the focal point of the topology. So let's go back over to here. This, I changed the priority to 0. Okay? This bridge is the root. Okay? Notice that every one of our links is forward. Okay? Let's go over to this one. Let's switch up here. As you can tell by the lights, okay, not all are actually forwarding. Only one link in spanning tree is forwarding. Okay? Alright? Now, remember, this is a spanning tree protocol working in the background. Okay? All right, as long as you're hooked up to another switch, spanning tree is going to recognize that by receiving BPTUs, and bam, it's going to start kicking in and doing its calculation. Okay, but with this switch here, which is the top switch here, that you can see, kind of faded because I selected it. Two of its links that are going to other switches are blocked. Okay, now, where are you? There you go. Okay, so your root bridge is the focus port of your focus port of your topology. It'll be the only switch where every one of your links are in forwarding status. Okay, so let's go back to our topology again. Okay, all right. Now this switch here, all its links are forwarding. Let's go back. Let's go here, which is not a root bridge. Okay, but they're all forwarding. Okay, all right. But this tells you it has a priority of 1. Okay, and look at this row here. It's a root port, meaning that this particular port takes you to the root bridge. Okay, unlike this one, all of them are designated ports. Okay, so it's not the fact that, yes, they are in forwarding status, but they're all going to be designated ports, where even a designated or a forwarding port on all ports, okay, they're not all designated roles. One of them is going to be the root port. Okay, let's take a look at this one, all the way up here in the corner. Okay, bam, root port. Okay, so let's take a look at this. Let's kind of see what we got here. We got a designated port as a role and a root port as a role. Okay, all right. Now, obviously, those are always going to be forward status. Okay, all right. But if it's not a root port, okay, lots of times on the other side of that designated port is going to be a block port, unless it is a root bridge. Notice that the root bridge, all are designated ports, but on the other side of those links are always forwarding. Okay? All right? Okay? Now, I'm giving you the information as if I wish I had it when it was given to me. Okay? However, just, sit back, relax. It's a lot of information. You're not going to get it the first time. You're going to have to rewatch it over and over again, read documentation, and you cannot understand it until you lab it yourself. Okay? So, what is a priority? Okay, the default priority plus the SysID extension. Okay? Let's take a look at that. Let's go into here. Show spanning tree, but I'm only going to look at it for VLAN 1. Okay, this bridge is the root. Okay, 32.768 is our default, plus our system ID extender, which is 1. Okay, all that means is, to make this simple, is, where did my, there it goes. All this is 32.768 is the default priority. Okay, now if we take that, because I told you they went by 4,096. Okay, 8. Okay, all right. So we're 8 numbers in to get 32.768, but the extender is This one is 769. VLAN 1. That's VLAN 1. VLAN 10. 78. Okay, that's 32,768 plus the extended VLAN 10. So all this system ID extender is just the number of the VLAN. Okay, all right, okay. That means that VLAN 1 is going to have a lower priority by default from that VLAN perspective, but you got to understand this. Okay, all right. VLAN 1 having a default of 32,769 is going to be the same priority by default on all the other switches. Okay? Alright? So just keep that in mind. Alright? Now, our port election. Okay. What is a root port? The root port is the best path to get to the root bridge. Okay? Now, the best path to get to the root bridge. How do we determine that? Alright? How do we determine that? Alright? Now, we determine it by the value of cost. Okay? So if we go back over here to this one. Alright? Each one of these links have a cost value. Okay? So if I go back to the topology, all right, these cost values are determined by the speed of the link. Spanning tree, by default, creates a default value for 100 megabits, 10 megabits, 1 gig, 10 gigs, okay? Now, if 10 gigs is 1 and you got a 20 gig link, you can manually go into Spanning Tree and change those cost values, okay? All right, so it's not written in stone. All right, so if a 1 gig link has a value of 19, which you saw the cost value over there in 19, okay? All right, meaning that from this switch to this switch, okay, 19 plus 19, okay, what is that, 38? That is the cost to get from here to here. Now, again, let's think about this. We are worrying about getting to the root bridge. We got a link here that's designated. We got a link here that's designated. But to get to the root bridge, 1938, 1938, 1938, and whatever 19 times 3 is, okay? But this one is just 19. So it's going to be our root port. It is the slowest cost to get to the root bridge. And it becomes our root port. Okay? All right? So, that is our root port election. Our designated and blocking ports. Okay, now listen carefully. All right? What is a designated port? All root bridge ports will be designated. I told you that already. All ports on the opposite side of root ports will be designated. I showed you that too because they're all green. All ports on the opposite side of blocking will be designated. Okay, and we did see that. Okay, let's go back here. Designated, all the green ones are designated. And on the other side, we'll have a blocking port, but look what it says. On the other side of a blocking port will be a designated port. Okay? All right? That means that this could be a designated port, this could be blocking. Okay? Traffic can go here through the designated port all at once, but it's not getting past the blocking port. It's going to get dropped. All right? So that is what kills that loop. Okay? Now, designated tiebreakers. Lowest cost to the root bridge, lowest priority, lowest MAC, lowest port ID. Okay, now let's take a look at that port ID. FAO24. Now, check this out, okay? On this particular switch port, looking at spanning tree, okay? I have all these VLANs going on that particular port, okay? All right, because remember, this is a per VLAN scenario, okay? But what if we look at the detailed information? Interesting, okay? This for VLAN 1, okay? That's all we're looking at. You know, down here is VLAN 10. We have a port priority of 128, a cost of 19, and our port identifier 128.124. Okay, so now, as we are determining who is the root bridge, we're going to go with the lowest bit ID, which is the priority plus the actual MAC address. Okay, that means we're looking at the MAC address of the actual switch, and whoever has the lowest MAC address becomes the root bridge. Now you got to be careful, because like VTP, all right, you're not going to destroy your network like you can with VTP, okay, by putting in a switch with a high revision number, but these MAC addresses, okay, the first 6 numbers of a MAC address, all right, is given to a manufacturer by an organization, okay? So they have no control of what those first 6 numbers are going to be, okay? If they, once they extended their usage of the last 6 numbers, okay, which is what they're going to build a network card, build another one, build another one, and build another one, and it's going to go, first 6 numbers are stationary and given to them. The last 6 numbers are going to be 00001, 00002, 00003. Does that make sense? Okay. And once they have extended or exhausted those numbers, okay, by maxing them out and they have no more to use, they'll go back to the organization and get another 6 digits in the first number and start all over again. All right. So if that's the case, okay, 0000, okay, or 0001, however you want to look at it, that's going to be like switch version 1, okay? And by the time we get up, we might be on switch version 5. Now, switch version 1, okay, all right, or model number 1, okay, if you want to look at it from that perspective, that was built in 1990. Okay, model number 5 was built in 2005. Okay, so that means putting a switch back in the 1990s is going to have a lower MAC address, meaning it's going to have a lower bit number, which means it's going to become the root bridge of your topology. Old technology, slower speeds, not being, not as beefy, whatever, okay? Packets per second is not as fast, all right? So you have to prepare how you're going to have these switches operate in your topology. If I'm going to have my switch sitting in the center like we did with the packet tracer, my switch better be fast enough, packets per second fast enough, okay, and RAM fast enough to hold the routing tables or the MAC address tables and the throughput of traffic. And if it's a distribution switch, oh my God, okay, we're doing policies there. We might be doing firewalls there. When I mean firewalls, like zone-based firewalls, okay, access lists, distribute lists, routing protocols. All right, this this switch needs to have the ability to do its job. Okay, so you just can't slap them in there, is what I'm trying to tell you. Okay, now, when I'm trying to determine from one link onto the other who's going to be designated, that means you're not the root bridge, okay? Because if you're the root bridge, all of them are going to be designated, but you're not the root bridge. All right, so you got two links. All right, your link and the opposite link on the other side are the point-to-point link. I need to figure out who's going to be designated. Okay, so if I have a lower cost than my direct link, I become designated. If I have a higher cost, he becomes designated. If I have, then these are tiebreakers, by the way. If I have a lowest priority, I become designated. Lower MAC, I become designated. Okay, all right, assuming that the priorities are the same. Does that make sense? Because these are tiebreakers, meaning that if the cost, okay, is the same, then I'm going to go to the lowest priority. Now, the priority is the same. Well, what's the tiebreaker there? The lowest MAC. Okay? All right? And when it comes down to it, it's going to be the lowest port ID. Now, I know what you're saying. How is that possible to have the same MAC address? It is when we go back to this topology here. Okay? And we have this type of scenario. Okay? So, is it possible for another link on that device to have the same MAC address? Absolutely. So the only way to figure out which one will be designated, okay, between these two links, between these two switches, is going to be the port ID. Okay? That's how you get the same MAC address in that scenario, and the lowest port ID is going to win and become designated. Okay? Come on, guys. Tell me that's not awesome. All right? This is what we call port election. Okay? All right? Now, we went up here and said root port election. Okay? But we still got other port elections, which would be the designated port. Okay? Anything else after that is blocking ports. And that's how spanning tree makes its topology. Okay? So what is a blocking port? This port will not allow ingress or egress traffic. Absolutely none. No traffic coming in or out. Okay? But it will still accept BBTUs because it has to. If it doesn't accept BBTUs, how is it going to know when to change that blocking into a forwarding port or a designated port when a topology change notification is given? Make sense? Okay? Now, speaking of which, okay, this is where we stop, okay? Because we're going to talk about topology changes on the actual next video. And as always, be strong, be determined, be Cisco.